Ever notice how old sailing ships look nothing like today's massive cargo ships? The old ships had deep, curved hulls, sleek and narrow, built for speed and agility. Modern cargo ships are wide, boxy and flat-bottomed, designed to haul as much as possible. Why the change? It's all about physics and profit. Old ships relied on weight stability. A heavy keel kept them upright, like a pendulum. Modern ships use form stability. Their sheer width and flat bottoms make them hard to tip, like a raft. The deep-hulled yacht is built for slicing through waves. The flat-bottomed cargo ship is built for maximum capacity. Both designs keep ships afloat, but each is optimized for a different job. The evolution from deep to flat hulls is a story of changing priorities, speed and maneuverability versus carrying the most cargo. Understanding this shift is the key to why ships look so different today. It's not about style, it's about what works best for the job. Let's dive into how these two approaches keep ships upright. Picture a hammer, heavy end down, it's stable. Flip it, and it topples. That's the principle behind old ships. A deep, heavy keel pulls the center of gravity low. The keel, loaded with dense material, keeps the ship's weight far below the waterline. Buoyancy pushes up. The keel pulls down. And together they keep the ship upright. If a wave tips the ship, the low center of gravity acts like the hammer's head, pulling it back. This method is simple and reliable, perfect for sailboats and even submarines. Submarines, for example, use heavy ballast at the bottom to stay upright underwater. The key: as long as the center of gravity stays below the center of buoyancy, the ship rights itself. It's a robust system, but it comes at a cost. Lots of heavy non-cargo weight. That's why you don't see deep keels on modern cargo ships. For them, every ton of weight matters. So, they found a new way to stay stable. Enter form stability. Modern ships ditch the heavy keel for a wide, flat hull. Think of a raft or an outrigger canoe, hard to tip even without much weight below. When a cargo ship leans, more of its wide hull dips underwater on one side. This shifts the center of buoyancy outward, creating a powerful righting force. The wider the ship, the stronger this force, like a lever pushing it upright. This lets cargo ships stack goods high, even if the center of gravity rises above the center of buoyancy. As long as the center of gravity stays below a certain point, the metacenter, the ship remains stable. Form stability trades weight for width, maximizing cargo space. It's clever engineering. Use the ship's shape, not just its mass, to stay upright. That's why today's ships are so boxy and broad. It's all about carrying more, safely. Ship stability comes down to 2 points: center of gravity and center of buoyancy. The center of gravity is where all the ship's weight balances. The center of buoyancy is where the upward force of displaced water acts. In weight-stable ships, the center of gravity is kept low, below the center of buoyancy, so the ship rights itself naturally. In form-stable ships, the center of gravity can be higher, thanks to the wide hull. As the ship leans, the center of buoyancy shifts sideways, creating a righting arm. The trick is to keep the center of gravity below the metacenter, the point where the ship will still right itself. This allows cargo ships to load high and wide, maximizing capacity. But it's a balancing act. Too much weight up high and stability is lost. Ship designers and crews constantly monitor these points to keep everything safe. It's a dance of physics and engineering. That's how modern ships stay upright, even when stacked sky high. Why do cargo ships use form stability? One word: money. Every ton of dead weight is a ton of lost profit. A flat, wide hull means more space for cargo and less wasted on heavy keels. Ports and canals have depth limits. A deep keel can keep a ship out of business. Flat-bottomed ships can carry more while sitting higher in the water, accessing more ports. The boxy shape is the most efficient way to pack goods into a floating warehouse. Once safety is met, every design choice is about maximizing cargo. The flat bottom isn't a flaw, it's the result of relentless economic logic. Form follows function, and the function is to move the most stuff for the least cost. That's why ships look the way they do. Ship design is a constant balancing act. Stability, strength, and profit all compete. As cargo is loaded, the ship sinks lower, increasing stability, but stacking containers high raises the center of gravity, Crews use computers to track every load, ensuring the ship stays safe and stable. It's not just about building a big box, it's about managing every voyage with precision. The flat bottom gives huge capacity, but it must be handled with care. Every trip is a new puzzle of weight, weather, and route. The modern cargo ship is a masterpiece of compromise, physics and economics in perfect balance. Next time you see a container ship, remember, that flat bottom is a triumph, not a flaw. It's the shape that keeps global trade afloat, and it all comes down to the art of staying upright, no matter what the sea throws at you.